Alright, these last 3 questions on the quiz review. The way we solve this problem is we need to construct a perpendicular line right here so that we end up with a rectangle and a right triangle. Here's a right triangle. Let's do this one in green. Because if we have the lengths, 2 of the lengths on the right triangle, then we can find the third one, which is right here, which is the same as this one since it's a rectangle. Opposite sides are congruent. Now, we'll notice that this whole thing right here is 12, and this whole thing right here, do it in a different color, is 9. Now what you'll notice is, again, opposite sides are congruent, so if this is 9 and the whole thing's 12, then this right here must be 3. Alright? Alright. Let's get rid of that and that. And then, as well, we know that since this whole thing is 12, which is the radius, that this whole thing, which is the radius, is also 12. And since we know that this whole thing here, the radius is 9, but again, this is a radius, so the radius of that circle is 9, so it should always be 9 on that circle. So let me pull out this triangle we're looking at so you can kind of see it on its own. We have 3, and then 9 plus 12, that's 21, right? So we can find x. This is the right angle here, so we should have that 21 is the hypotenuse. So 21 squared is equal to x squared plus 3 squared. Long story short, we get 20.78461, and we'll just round that to 20.8. So there's the value of x there. Now this one we know again, and we're just going to assume that these are tangent segments. That's something we shouldn't naturally do. This is what we've been working with, this theorem, the 2 tangent segment theorem, which means that this is congruent to this. Therefore, if AB is represented as 2x squared plus 4, and AD is represented as 22, and we know that those 2 line segments are congruent, then those those expressions are equal. So we can make this equation here. If that equation is true, then we can do some algebra. Subtract 4 from both sides, we get 2x equals 18. Sorry, 2x squared equals 18. If we cut both of these in half, we'll get x squared is equal to 9. Therefore, x is equal to plus or minus, I'll just write it like this, 3 comma negative 3. And typically we want an answer that makes sense, and if we do plug 3 or negative 3 in here, we just need to make sure that the outcome of plugging negative 3 and 3 gives us with a positive value, because distance can only be positive. You'll notice with the x squared value, 2 times negative 3 squared is just positive 9 plus 4, and that should give us 22. So if it worked for negative 3, it should work with positive 3, so this is a sufficient answer. Our last one here, we have again the 2 tangent segment theorem, which states that these are congruent, and since they're congruent, we can set the expressions that represent them to be equal to each other. So we have this expression here, in this equation, 10x squared plus 14x minus 12 equals 0. What am I doing here? Well, I see it looks like a quadratic, right? And we have x squared value and an x value. So unlike this previous one, we didn't have an x value on this previous one. So we were able to just subtract 4 from both sides. We were able to just have a single x on one side of the equation. Here though, we have to factor this out. It must be factored. So we need to set it up like a quadratic, right? This is very much like a x squared plus b x minus c equals 0. Now you could, if you wanted to, use the quadratic formula, which is negative b, I'll use the actual color, plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. I think though it's easier to factor, in my opinion. So, well, first things first, we'll notice that there's actually a GCF that we can factor out. So 2 should work. 2, and then inside we have 5x squared plus 7x minus 6 equals 0. And then this is all we really have to work with for factoring. Because if what's inside the parentheses ends up equaling 0, if we multiply it by 2, it still equals 0. So we can work with just solely this. Alright, what's the first thing we do? Let me use some different colors. We multiply the leading coefficient and the constant to get our product. So I'll do this little t-chart to help us out. Our product is 5 times negative 6, so negative 30. And then we know that our sum needs to be that middle term. So this middle term is 7. So what are two numbers that multiply together to get negative 30, but when you add them together you get 7? Well, we'll start out with the ones we know, right? Negative 6 times 5, and negative 5 times 6. Yeah, those don't really look like they sum together to get 7. How about 10 and 3? 10 times 3 equals 30. Ooh, which one should be negative? The 10 or the 3? Well, since our sum is positive, we want the bigger number to be positive and the smaller number, so 3 in this case, to be negative. So 10 times negative 3, because 10 minus 3 equals 7. So this is the winning set of numbers. What we do with that is we break this middle term into those two numbers, 10 and negative 3. So we have, we'll just keep that 2 outside so we don't forget about it, 5x squared plus 10x minus 3x minus 6 equals 0. Let's get this out of the way. Okay, there we go. So, throw this in the box. It's a weird box. 5x squared, 10x, negative 3x, and then negative 6. So, for this one, we should get 5x. And this one, we should get x, right? That's the greatest common factor from the first row. And then this right here is the greatest common factor of the first column. Now, we know that 5x times 2 equals 10x, so that works. And if you actually look at this column, you'll see that 2 is the greatest common factor there. And then also, we know that x times negative 3 equals negative 3x. So we just double check, make sure that whatever box you're looking at, it's the product of that column and row where they intersect. So here we are. We have 5x minus 3, and we have x plus 2. And again, we'll just make sure we keep that 2 out front. It doesn't actually matter, because if what's inside the binomial ends up equaling 0 for the given value of x you need, then the whole thing is equal to 0, because it's just 2 times this binomial times this binomial. So 0 times whatever equals 0. So what we can do is just set each of these binomials set equal to 0 to find the values of x we need. For the first one, let us add 3 to both sides. End up with 5x equals positive 3, and then divide both sides by 5. And we end up with x equals 3/5. And then for this one, all we need to do is subtract 2 from both sides. And we end up with x equals -2. So we have these two values for x. And when you plug those values back in, you should have that they are positive. So I'm going to use the negative one just to show. We have 10 times -2 squared plus 14 times -2. Let's just ensure that this is going to be a positive value. So -2 squared is 4. 10 times 4 is 40. 40 plus, and then this would be -28. And that equals 12, positive value. So truly, both of these answers, x equals -2 and positive 3/5, are your solutions.